Our next speaker is Juan Pablo Orozco. Juan Pablo is part of the CIGOM consortium, and he is at the Center for Research and Industrial Development, or at least that's where he did a lot of the work that he's going to present now. He is currently an associate professor at Anahuac University in Campeche, and he's going to talk about the Mexican underwater glider that he's been working with Tomás Salgado at CIDESI for the last few years. We can't hear you, Juan Pablo. Hang on.
Did you hear me?
Now we can hear you. Can you put your presentation in full mode?
Okay, thank you very much. I will. Okay. It's okay. Okay.
Perfect.
And then, okay. Thank you very much. Okay. Well, my presentation is about one of the technological developments from the consortium CIGOM. That is one of the perspectives that CIGOM had since the year 2015. Well, this is the Mexican white. I don't know why it's not okay. Perfect. Well, for the people that don't know what is an underwater glider, well, it's an oceanographic platform that is from the family of the autonomous underwater vehicles that have the main feature to have a propulsion system based on variable buoyancy system. This kind of vehicles didn't have don't have a propel, have only a variable buoyancy system that increase and decrease the volume in itself to generate the descension and the ascension of the vehicle in the water. Okay, have another elements that are very important, like features, that is the low consume of power and high autonomy. The commercial gliders have an autonomy of 4 months approx, depending the instrumentation and the sensors installed. Now, the main trajectory that follow this glider in the cycles, well, are called the sawtooth pattern because we have to fly in the water to reach certain distance for travel. And this kind of gliders takes parameters for the column water to take these parameters and to make an interpolation in the transect that is provided. Okay, this is the next generation from the profiling floats, but have different properties too. Okay, well, the basic of flags about the glider. If we take the glider like a aerodynamic profile, we could observe that we could have the lift and the drag forces that will generate or can be compensated the resultant with the inertial force that is called B. That is the net buoyancy force that we will have in the vehicle. That depends from the mass and depends from the volume displaced from the water, and that will generate us this compensation or this stability in the forces. This stability in the forces will give us an angle, a glide angle, that is the effective angle that we use to make it possible the transects and the advance from the glider. Okay, well, this prototype that was developed from with the CIGOM project started in 2015 and ends in the year 2021. And we started from the beginning. We didn't know nothing about this technology. We have to start with the study of the with the scientific study about the papers, about the technology, about the patents that was in the field, to try to understand or to integrate several systems in the commercial systems. We could not have the main systems that are required in the glider. So all the main systems that we could show, for example, here was developed here in Mexico, was developed by us, and was constructed by us, following the main information that we had about the performance of the gliders. Okay, well, I want to talk about some of these important elements. The main one is the pressure hull. The pressure hull is the main element where is contained all the electronics, all the principal systems that have to be inside the hull and have to not to be in contact with the water. Okay, the main computer, that is all the architecture, the electronics that make it possible, the performance and the movements of the systems, is the brain of the glider. And the steering control systems, that are basically masses that make it possible the inclination of the vehicle in this direction, or to rotate the glider in another direction. Okay, we could observe that deeper in another slide. The variable buoyancy system, that is one of the main characteristics of these vehicles. And from this glider, Mexican glider, we developed a CIDESI-X rechargeable battery of lithium ion, okay, with a one special configuration that is in process to be studied if could be patented. Okay, so I will show you only the first version, but the real version is in process to be analyzed. The graphical interface for the system control and the monitoring, well, is the platform from the control. Okay, well, this is the battery. This is only an schematic diagram. This is not the real diagram for the batteries that we have here. But we developed it. We tested the batteries to make it to make sure that the available power and the currents that we require could be necessary to feed the system. We have the pitch system that you can see here. That is the linear mass, that is the battery, that is moved from the outside to the forward side of the vehicle to make it possible the inclination. And this system, that is the roll, this roll is an eccentric mass that could generate a sweep in the glider to generate the change of direction and generate another type of transients. Okay, the main design was developed like a rack system. Okay, all the systems are interconnected to generate only one assembly that could be that could be put inside the hull without having error of connections here. Okay, well, this is the hull. The hull is an aluminum 6061 T6 that was finishing with electrostatic paint and was machining inside to make it possible the sliding from the rack with the electronics. And well, you could observe here the bases to attach the wings in the glider. Now, for this prototype, we used the FDM and additive manufacturing in ABS to generate the wings, to generate the tail, and to generate the nose of the glider. Okay, there are elements that are in contact with water, and that is in the wet areas. We will observe the wet areas in another diagram here. Okay, you can observe the manufacturing process and the finishing process that was made with an epoxy paint to make it possible the aeration in the ABS. Okay, one of the principal contributions that we obtained with all this study was to solve one important question that was opened a time ago. That was the relationship between the parameters of flight, or the aerodynamic parameters, with the flight parameters that we have. For example, in the sea gliders, we work with sea gliders. We have these calculations inside the software, but we don't have the complete information about how we could make the relations between the limits and with the proper quantity of flag. Okay, in this case, we published the last year one article that is the part one from my thesis, that is the study about the sizing from the BBS, that is the propulsion system, that is the required volume that you require to make it possible the flight of the vehicle at a certain velocity. Okay. In my PhD thesis that was dedicated to the development of the BBS. Well, was generating a mathematical model to obtain the estimated efficiency of the BBS. That is one of the important part in the gliders. With a conservative values of efficiency in each step of connection. In the reality, we had a better efficiency in the point of operation, that is 200 meters deep for this glider. That is around 50% of efficiency. That is the higher efficiency that was documented in one commercial glider, for example, that is the Slocum for coastal operations. Now, so this is one of the main contributions that give us the elements to put all these equations in the computer to make it possible the flight. Okay, well, this is the rack assembly. This is the rack concept that we had to install the electronics. We make it possible the testing in laboratory. We performed a low cost testing bank, and then sorry, my computer. Okay, this is the complete sheet about the elements from the Mexican glider, with the elements that I explained it. Okay, this is a good view about the glider, with all the elements that have one commercial or one industrial glider. Okay, and we performed extensive laboratory testing to go at the final point, that was the C-trials that was in the last year in Ensenada, Baja California, in August of 2021. Okay, this is the equipment of CIDESI that was working in the C-trials. We had the support of the people of CICESE to work in Ensenada, Baja California. That was very great to make it possible, this element. Okay, I will finish with this video. That is the culmination of the C-trials. We will observe we can observe that the vehicle is going to the upper side, and then we have one sequence for the transmission and recovery. Before we have 5 meters deep, we generate the pitch control system to have the antenna in the higher position, and then we inflate all the BBD to generate the extra buoyancy that we require to make it possible the communication with the satellite. All these testings was at 50 meters deep, and we intend to improve the glider to a next version. Okay, well, I will go faster. Okay, and this is the element. We have the one CTC sail sensor. In the lower part, we have an altimeter. That is one basic configuration for the gliders. No? And well, when the glider is in the surface, well, the antenna is in the position for communicate. Okay. And well, the future for this technology, we are trying to acquire finance for the next version. We have with this development, we had the elements to make it the improvements and the added values capabilities to make it possible that. Okay. Well, for me that's all, and this is our contacts if someone wants to contact us. Okay. Thank you very much.
Thank you, Juan Pablo. Okay, we're a little over time, but we have one question right now in the box. We'll get to that one first, and then please raise your hand or just open your microphone if you have additional questions. I have a question here for Edgar from Stephen Johnson. He says that you had in your presentation the Valley of Death, and in the UK they have a group called ORE Catapult, and he gives us that link, and he was wondering if Mexico has a similar organization.
I am not very familiar with the organization, but of course that I can check if you can send me the link and we can check. And even though we have a similar organization in Mexico or no, we can make links internationally. So if you're interested, of course, that we can work on that. Just please be sure that you send me the link to check it.
I'll do that. Any other questions? I can't see the attendees. I think you can open your microphone and ask questions if you have them. Okay, I'm not seeing any questions, so I'll pass this presentation to Jorge.
Sharon, thank you so much. Well, I just want to have the opportunity to thank all of our 4 speakers today. It was, I mean, really interesting and surprising to me how I increased my understanding on renewable energies. And also, you know, I just can't believe how the Mexican Glider project really started with Juan Pablo's PhD dissertation. That's just in itself amazing that now they have a working prototype. I just have a few final remarks that I want to make. First of all, I want to thank the CEMIE and CIDESI consortia speakers and partners and colleagues who have joined us for this 4 webinar series, actually 5. We ended up having 5 sessions throughout the course of this spring for the quality and the comprehensiveness of the work. It's really very interesting to me how, you know, with this series of webinars, we're able to have a better understanding of what Mexico is doing. I also want to thank my organizing committee, that's you, Sharon, and also Dr. Zenon Medina with End-to-End project at Texas A&M University, and Tricia Hill with SGT, president of the Society for Underwater Technology as well. And also thank the GCOOS team who have helped us to make this happen, especially Jen Breland and Chrissy Morelli, but many others who helped us throughout these several months that we hosted these meetings as well. I'm really amazed by the diversity and comprehensiveness of the work. I mean, really, how CIGOM and CIDESI have been able to take, you know, basic research into working science and applied science. That it's very important for the things that we've discussed throughout this webinar series, like the scenarios for the oil spill, for a future also potential oil spill in the future, but also many other needs that to understand this Gulf of Mexico as a whole system. Also diversity of observations and the assets that they were involved in developing the environmental baselines that you did, the publications that were developed, and the data management capacity. I was also especially surprised by that as well. And I'll just end by saying, most important, I think the technology, the results, the science that we saw over the past 4 webinars, 5 webinars again, including the publications, are the results of a very high level of organization and management that CIGOM and CEMIE have. And that has been shown, I'm pretty sure, I mean, that's clear to everyone that that's been shown throughout the many presentations that we've seen, how we're able to put together this amazing and large project for the past 5 years in gaining all this understanding. I also think this is the result of a renewed interest in Mexico for understanding marine science and how important that is now for Mexico and as it is for us here in the United States. And that have turned out to be, you know, a lesson for us to, as you guys develop the atlas that, you know, actually shows a whole system, the entire Gulf of Mexico. And so all the products developed were for the entire Gulf of Mexico. And I really enjoy and appreciated that. I hope that others did as well. And I'll just end by saying that, you know, this is a community, it was shown to me that this is a community that had already done many relevant contributions to marine science, marine understanding, the industries working in the Gulf of Mexico, and the things that we care for to the future, as Semilla shows us today, their work on renewable energies, and how, you know, these two marine consortia have a lot to contribute to the future. So I'm looking forward to that opportunity, Sharon. I hope that others who have joined us are on the same thinking, but we're very interested in continue this conversation and learning from what we can do together and what you guys have done in the Southern Gulf of Mexico for Semilla and CIGOM. So Sharon, do you have anything that you would like to add?
No, just thank you, GCOOS and SUT-US, end-to-end, Gulf of Mexico, Texas A&M for this opportunity. Hopefully this will be the starting point for linkages between groups that are working in these various marine Gulf of Mexico related fields in Mexico and the US. I think it's very clear to many of us that there's a very, very big need for that, particularly facing very large environmental changes in the Gulf over the next decades that threaten a lot of the ecosystem services in the communities that surround the Gulf. So thanks for everybody that took the time to assist to these webinars and for the opportunity to present what we've been working on with these two Mexican consortia.
Well, and again, thanks to Dr. Senor Medina and to Tricia Hill, our partners in crime here for organizing this webinar series, and to everyone who has attended today and in the past, thank you so much. And with this, we finish the GCOOS Spring Webinar Series, and thank you, everyone. Have a great day.